So just doing another example of solving vectors graphically. We're using scale diagrams, protractors, rulers. There's no calculations yet. Once we're moving into calculations, I'll make the connection for you between how they work from graphical and then how it breaks down into doing mathematical calculations. Anyway, ahead of myself. So we've got four forces pulling on an object in 2 dimensions. One force is acting west 20 newtons. Second force is 45 newtons, east 30 degrees towards the north. Third force 35 newtons, east 60 degrees south. Fourth one 25 newtons, west 45 degrees south. So east, west, north, and south is easy to picture, but if you want to picture it like just four, you've got an object with 4 pieces of rope tied to it. People are just standing around pulling on it. You could do left, right, up and down, or X and Y axis. You could do it the same way. But I'll stick to north, east, south, and west. First, we set up our starting point. Now, thinking it through a little bit, we're using a scale of 1 to 5. The biggest line I'm going to have to make is 9 centimeters, and it's kind of northeast. So try to picture this before you even do it, so you know where to make a starting point. So it's going to go 4 centimeters west. Right, just hello, go away. So just over here on the end, I'm just going to write how long these are going to be. This is going to be 4 centimeters. This is going to be 9 centimeters, 7 centimeters, and 5 centimeters. So go 4 centimeters west, then northeast, 9 centimeters. Then it's going to go southeast, 7 centimeters. So in a rough path, like this, northeast, southeast, southwest. So that's just to get a layout of where I'm going to put my starting point, because some people, you're doing your work and you're running off your page. Right? So let's do this one out. My starting point, I think, is going to be all right. I might move it a little bit this way. First one is due west, so I don't have to actually use my protractor at all. So it's just straight west. I use my ruler and I measure, I forget my number, 4 centimeters, thanks. So my ruler is a little bit backwards for measuring west. So 4 centimeters due west, and my arrows, I might have to make them a little size, resize them for my diagram, my ruler. There we go. There's my first vector, 4 centimeters west. So if I'm labeling that, which you should, and I'll remind you again, so that's just, I'm just going to label it F1. Okay. It's 20 newtons west. F2 is now northeast, east 30 degrees north. Here's where your protractor comes in. So we're using the tip to tail method. Always put your protractor at the tip of the arrow that you just drew. Your protractor is always going to be vertical or upside down. Don't put your protractor northeast. Make sure the base is along east or west. We're doing east 30 degrees north. So my protractor, I put my finger pointed towards east. There's east 30 degrees towards the north. That way. So I put a little dot near that point and a 9 centimeter line through it. So I might have to readjust my little line here. So my angle's good. And rotate my ruler. 9 centimeters. Stop it. There you go. Right around there. So that's east 30 degrees north. So the angle in between those two vectors is 30 degrees. Next one is now southeast, I think. It's going to be 7 centimeters east, 60 degrees south. When we're working south, I need to rotate my protractor. There we go. I put anything south, I could put it completely upside down. A little crooked. Hello, there we go. Around there. Always putting it at the end of the arrow you just drew. And now I'm going to go east, 60 degrees towards the south, big angle south. And I'm going to make that arrow 7 centimeters long. It's faster to do with your paper than it is on this thing. There we go. Just getting them parallel. Really? And 7 centimeters. So we remember, the arrows will not look like 4 arrows pulling on an object, but it does make adding up the vectors a little bit easier. And the last one, 5 centimeters, west 45 south. So we're still going south, so protractor is still going to be upside down. So it's point west, and then 45 degrees towards the south. Make your 5 centimeter line through that point. That's pretty close. Now I have to adjust the size of that arrow. Ooh, there's an angle measurement on my ruler. I did not know that. I would have made things a little bit faster. Five centimeters. There we go. Somewhere around there. And then there's a blue line in there for some reason. Not sure why that's there. And same with the other one. So once we have our final arrow drawn, you want to figure out the resultant. It is always from your starting position, pointing to where you ended up. That's our resultant arrow. You measure that with your ruler and your protractor for your angle. Go. Really, come on, there we go. So on mine, it's going to be a little bit different than yours, possibly. I get east 52 degrees south, and it's about 6.5 centimeters long. So 6.5 times 5, is that 32.5 newtons? So my resultant force, which is net force, is 32.5 newtons. Take a better end than that. It's east and then 52 degrees towards the south. So whoever was pulling on those coordinates, if you can picture this in your head, 4 people pulling on that, it's going to move kind of southeast, whoever's positioned that way. It's not going to go towards somebody, it's going to go in between 2 people that are pulling it. All right.